Let's finish out the examples here on our handout. Example 7. The Cameron Arts Center is planning a fundraising dinner. The costs include a speaker's fee of $2,000 and publicity costs of $700. Okay? So the speaker is going to cost us $2,000. Publicity is going to cost us $700. If they hold the dinner at the convention center, it will cost $600 for the use of the center and $20 per plate. So if we do it at the convention center, it's $600 plus $20 per plate. The admission charge for the dinner is $35 per plate. So we're going to charge $35 per plate. How many tickets to the dinner must be sold to break even if the dinner is held at the convention center? All right, so let's answer that question first. Well, that's a break-even question, isn't it? How many tickets do you have to sell so that you break even? To figure a break-even point, you have to know your cost function and your revenue function. And it's really coming down to some fixed costs, right? Fixed costs for the speaker and the publicity and the use of the convention center. And then $20 per plate. So wouldn't our cost function here, where we're letting X represent the number of plates that we're going to plan for, the number of people who will attend, is $20 per plate, $20 per person, plus the fixed costs of $2,000 for the speaker, another $700 for publicity, that's $2,700, plus another $600, that's $3,300 if we use the convention center. So here's our cost function. That was a relatively simple cost function to find because we were given the fixed costs and we were given the per item cost, weren't we? We were given the slope and we were able to add up the figures to give us the y-intercept of our linear function. And now we know how much we're going to charge, so that enables us to write our revenue function. So if we're going to charge $35 a plate, this revenue will have to sell enough plates, we'll have to sell tickets to enough people, that the revenue will cover the cost. So how many plates, how many people, how many tickets would have to be sold? Revenue has to equal cost for a certain number of tickets, plates, people. 35x minus 20x is going to give us 15x. 15x equals 3,300. If I take my calculator, 3,300 divided by 15 gives me 220. So if we go to the convention center, we've got to sell at least 220 tickets to break even. If we go to the convention center, we've got to sell at least 220 tickets so that the revenue will cover the cost. Well, that's not the only place that we could go to have our fundraising dinner. We could also have our fundraising dinner at another location. Let's look at the information about that other location. If the dinner is held at the Farrell Center, it will cost $1,300 for the use of the facility and $17 per plate. So if we have the fundraising dinner at the Farrell Center, it's going to cost $1,300 plus, $1,300 plus $17 per plate. If the admission charge remains $35, how many tickets must be sold to break even at the Farrell Center? Well, our revenue function is going to be the same, isn't it? 35x, we're still selling the tickets at $35 a piece. But now the cost function is different when we go to the Farrell Center. It's $17 a plate. So that'd be, if x is representing the number of plates, the number of people, the number of tickets, 17x, plus 1,300 plus the speaker and publicity costs, 1,300 plus 700, that's 2,000, plus 2,000 is 4,000. Our fixed costs are $4,000. So now my break-even function, my break-even calculation looks like this. 35x equals 17x plus 4,000. Subtracting 17x from both sides, I get 18x equals 4,000. Take my calculator, 4,000 divided by 18 equals, repeating twos, 222.222222. Well, you can't sell partial tickets. You got to sell the next whole number of tickets, which would be 223. So if we go to the Farrell Center, the break-even point, we have to sell 223 tickets in order to break even. If we go to the convention center, it only takes 220 tickets to break even. If we go to the Farrell Center, it takes 223. So the question is, which is the better location at which to have our fundraising dinner? And that's kind of hard to say, because if we were only expecting 220 people, then the convention center is the place to go, because we would at least break even, wouldn't we? But we would lose money if we went to the Farrell Center, because it would take us 223 people to break even at the Farrell Center. But once we get beyond these numbers so that we are breaking even at either location, then we have to start looking at profit. With the convention center, we were going to be paying what? It was the cost function there was 20x plus, what was our cost function? Cost function we had, what, 600 plus 7 was what, plus 3,300, wasn't it? So once we get past the points of breaking even, then at the Farrell Center, we're actually making $18 a ticket. Whereas at the convention center, we're only making $15 a ticket. So a person, to know which would be the better place, would have to know how many people do you plan to have attend, and what happens with the profit when you get to that number of people. Is it more profitable at the convention center or more profitable at the Farrell Center? So one way we could analyze that would be to calculate the profit functions for each of those settings and see which one comes out better. But again, this type of break-even analysis can be helpful when you're trying to make a decision such as this.